So now we're going to solve for trig equations, whereby you are given the trig equation. There's an equal sign, there's a variable, and you're going to need to solve. Now, keep in mind, we have our restrictions. Your answers must be between 0 and 360. So there's many different ways to actually solve this question, many different perspectives to solve this question. I'm just going to show you one. So in this case, from the previous video, we know that sine is opposite over hypotenuse, or opposite, or we can say that this is y over radius. So think of a circle. I'd like to, when we solve trig equations, think of a circle and think about the quadrants. Now, I did say that r, in this case, is always positive. Oh, we have a positive 4. That's great. Y is also positive. So I want you guys to think of where this terminal arm is, or this radius is, in what quadrant. So think about what's happening. So I'm going to draw you 4 case scenarios. Either it's going to be quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And all the radiuses here are always positive. And think about the y's. Now it says here that y must be positive because the question itself is only positive. So y is positive in quadrant 1. So I'm going to here a little dot. It's a positive y. And here it's also positive y. So I know my principal angle of these two arms is in quadrant 1 and 2. And therefore, we're going to erase these ones here. We don't need these ones here. All right, now we can actually calculate the angle. Well, how are you going to calculate the angle? You look at your equation. You take the inverse of the equation. And let's figure that out. And we end up getting 49 degrees. So the calculator will give you 48.59. I'm just going to round it up to the nearest whole degree. Now, where is 49 degrees? Oh, that would be in quadrant 1. So in this case, your answer gives you directly the first principal angle in quadrant 1, which is 49 degrees, and which actually matches our restrictions. Now over here, we got the answer for quadrant 1, but we need to get another angle for quadrant 2 because in our picture, we have 2 different angles. So in this case, we need to go from here, initial arm, all the way to the second quadrant. And keep in mind, we know that the calculator gave us this one here, which is 49, and this little piece here, the related acute angle, is also 49. So how are you going to calculate the principal angle of this red curve here? So you're going to go a full 180 and then go a bit backwards with the related acute angle. That means you have to take 180 minus 49, which gives you 131 degrees. And therefore, you're going to have 2 answers. So 49 degrees and you have 131 degrees. So it's very important that you imagine in all your trig equations where the terminal arms could be. Because sometimes you can get 1 answer, 2 answers, or 3 answers depending on what the ratios are. Okay, so now we have a secant. And secant, we know that you cannot take the inverse of secant because you don't have that number, that button on your calculator. I don't think so. So secant is related to cosine. So if you recall, cosine is a reciprocal of the ratios of this. So imagine, but miss, where's the fraction? Well, this is over 1. And if you take the reciprocal of this, that means you end up getting negative 1 over root 2. And in the past, you can rationalize this if you want to. This is one of the special ratios from the 45 degrees. But if you didn't know that, then you would take the inverse on your calculator and it would give you 135 degrees. So what that means is, in this case scenario, the calculator will give you an answer in quadrant 2. Quadrant 2. So from here to here is going to be 135 degrees. And just to practice, how do you find the related acute angle? Well, the related acute angle is going to be 45 degrees. 180 minus 135. Now, some students will just stop and finish and assume that this is the only answer. But this is where I'm going to stress that you're going to have to actually imagine where this terminal arm could be. Okay, so let's start off with cos theta is equals to negative 1 over root 2. And let's actually address what cos is again. Cos is related to what variable, x or y? It is the x. So in this case, the top number can be considered the x, and the bottom number could be the r, the radius. So in this case, radius is always positive, so this is always positive, and therefore in my case, here the numerator part is x is negative. So you need to imagine where x is negative. What quadrants is x negative? Well, your calculator gave you this answer here, and we know that x negative is on this side here, So in quadrant 2, the x is negative, but also in quadrant 3, x is negative. In other words, this related acute angle here with the x-axis in the left side is 45 degrees. So we have another answer. So our other principal angle is from initial arm here and go all the way around past the 180 and go a little bit more with the RAA. In other words, our angle here is going to be 180 plus 45 degrees, which is 225, and therefore theta has two answers, one in quadrant 2 and one in quadrant 3. So let's address tan right now. Somebody's talked about sine and cos. So this looks a bit more complicated, but it's not really. You just have to isolate tan theta on its own. This is called a linear trig equation. So we're going to isolate tan as much as we can. We're going to add 2 on both sides. And we add 2 on both sides. This becomes a negative 3 plus 2. And then after this, it becomes a negative 1. And tan theta is going to be negative 1 over 4. And then this is where you're going to stop and think of where the terminal arm could be. Because if you just put this in your calculator, it's only going to give you one answer. And in most cases, as I said, you're going to have either more than one answer. All right, so think about, before we use your calculator, imagine where this is. So you have a couple of things. Now, tan refers to which variable, x or y? It refers to both. It is actually y over x. So the question right now is, which one is a positive, which one is a negative? So the way that I wrote this fraction right now, it seems like y could be negative and x could be positive. So if I were to draw this out, y is negative down here and positive, it would be in this quadrant here, quadrant 4. I'm going to draw this here. So x is positive 4 and y is in the negative here. But hold on, miss. Before you said that this negative could be either on the top or the bottom. So can it not be 1 over negative 4? And the answer is yes. You have another option. Now y is positive, but x is negative. So y is positive and x is negative. Think of where that is. So x is negative on this side here, but y is positive. So we could have another possible arm in quadrant 2. So this is why tan is a bit on the funny side, because the negatives can go on either top or bottom. So let's have a look at this question now. So now we can actually put this in our calculator and figure out the inverses. Let's see where the calculator gives us. And the calculator gives us negative 14 degrees. Now keep in mind, I do not want to have my answer to be in the negatives. It must be positive. So there's a couple ways you can do this. You can, if you remember what coterminals are, we can just add 360 and will give me my answer. And if I did that, 360 minus 14 would give me 346, and which is in quadrant 4. Because this is 270 and this is 360. So your answer gives you in quadrant 4. Or you can think of backwards. We go a little bit backwards. That's negative 14 degrees. But negative 14 degrees also helps us to figure out the related acute angle in quadrant 2. So I'll put here quadrant 4, and I know I have another answer, which is in quadrant 2. And over here, let's use red. So let's go from initial arm, go all the way around here, which is 180, go a little bit backwards. And we end up getting 180 minus 14 degrees, which is 166 degrees. So then we have actually two answers to our equation. Let's do one more example with cotant. Now cotant, you need to imagine what this looks like. Cotant is actually the the reciprocal of tan. In other words, we're going to take this ratio here, which is the same thing as 1 over 1, and take the reciprocal, which is also 1 over 1. And now you have a choice to put in your calculator, but your calculator is going to give you one number. Regardless, you kind of have to think of where the other answer is. So let's think of this. In the previous slide, it was y over x. And in both cases, it seems like they're both positive. So we have 1 over 1, y and y are positive, and x are positive. So what quadrant is y positive and x positive? In quadrant 1. So I'm going to draw a arm here. But you have to keep in mind that there's also another possibility. And you're wondering, what do you mean? Well, 1 over 1, if you make them both negative, when you divide these two, they become a positive. In other words, x and y could both be negative and negative, because these two fractions are equivalent, because the negative will cancel to become a positive. So we have another option where x is negative and y is negative, and that would be in quadrant 3. You take your calculator and take the inverse, or if you're you're taught to like memorize those or know those trig ratios, we end up getting 45 degrees. And this is in quadrant 1. So in other words, this little piece here is 45 degrees. That's quadrant 1. But we know that this related acute angle is also 45 degrees. In other words, we're going to have to figure out the principal angle, which starts from initial arm of 0 degrees, go all the way around. So your other answer is going to be in 180 plus 45, which is 225 degrees. So now we're going to actually look at an overall picture of all quadrants and looking at the signs of the trig ratios. So let's look at quadrant 1 first. Now, if you substitute a number between 0 and 90 degrees, what's going to happen? What kind of numbers are you going to get out of the trig ratios? So now notice x and y are both positive. And if you recall, sine is related to y and cos is related to x directly. So that means sine, which is pretty much y, is going to be positive. So if you substitute, for example, sine 45 degrees, you're going to get a number that is going to be positive. Same thing for cos. Cos is x, is related to x. You substitute cos 45, you can get a positive. Now tan, if you recall, is opposite over adjacent, or y over x. And if both y and x are positive, positive divided by positive will give you a positive. Now let's move on over to quadrant 2. Now, quadrant 2 is between 90 and 180. So what happens if you substitute an angle into each of these three ratios? What kind of sign are you going to get? For example, if you substitute 150 degrees, for example. Well, keep in mind, x is negative in this quadrant and y is positive. Now, sine is related to y, and y is going to be positive in this quadrant 2. X is going to be negative. And if you compare y over x, positive divided by a negative will give you a negative. So what that means is if you substitute, for example, 100 degrees, tan 100 degrees, you're going to get, your calculator is going to give you a number that is a negative number. All right, let's move on to quadrant 3. Quadrant 3, both x and y are negative. So what that means is sine is going to be negative because the y is negative. Cos is negative because the y's are negative. Now tan, now you got y divided by x, but both y and x are both negative. A negative divided by negative is going to be a positive. So what that means is if you substitute a number between 180 and 270, such as 240, for example, if you type in tan 240 in your calculator, you're going to get a positive number. Now, last but not least, the last quadrant is between 270 and 360. So what happens if you substitute, for example, a number between 270 and 360, such as 300 degrees? So what happens to the signs? All right, we're going to look at the sign. Recall in this quadrant, x is positive and y is negative. Sine is related to y is negative. So the number that you substitute in here between quadrant 4, the angle is going to be a negative number. Cos is positive, and if you have a mix of both positive and negative, positive divided by negative is going to give you a negative. So this is a recap of the signs of all trig ratios in each of the 4 quadrants.